So the next topic we have to learn is rational number. How do we represent rational number on the number line? Children, we have studied, I have explained you in my previous videos how we represented integers, right? Negative integers, 0 and positive integers on the number line. We did addition, subtraction also on the number line, right? We learned the rules of addition, subtraction, everything, right? So but here now we have to represent rational number on the number line, okay? Rational numbers on the number line. Okay, so this is our next topic. So here you have to recollect little bit about fractions. Okay, you have learned fractions. I'm sure you must have learned fractions. So fraction is nothing but part of whole, right? That's how we define fraction. So if I say write 2 by 3, what kind of a fraction it is? It is a proper fraction. Why it is proper fraction? Because your numerator is smaller than the denominator. There is another kind of fraction. If I write 5 by 3, this is improper fraction. Okay? Because your numerator is bigger than the denominator. So when we divide 5 by 3, we get 3 ones are 3, 5 minus 3, 2. So we can write it in the mixed form 1, 2 by 3. Okay? So here if you see 2 by 3, here it is lying between, see the proper fractions lie between 0 and 1. Okay, but here when we see improper fraction, when we divide, we get a combination of a whole number and a fractional part. Okay, so here if you see it is 1, 2 by 3. So it is understood from seeing this mixed fraction that it is lying between 1 and 2. Okay, now what you have to learn is you have to represent, you have to write this only on the number line. How do we represent these kind of proper fraction, improper fraction on the number line? That's what you have to learn. So I will take this example only to show you on the number line. So first example, if I say 2 by 3. So when we write a number line, normally we draw, I start, because it's a positive rational number, I will not take the negative integers, okay? I will not take the negative numbers. I will start with 0. Okay, now equal divisions you can make 0 to 1, 1 to 2 also equal divisions, 2 to 3 also equal. Okay, with the scale you can measure equal distance. Okay, now it is 2 by 3, right? Now between 0 and 1, what you have to do is, how do I represent 2 by 3 on the rational number, on the number line? So between 0 and 1 you have to make 3 parts, because it is 3 out of 3 we have to write 2, right? So I will make 3 parts, 1, 2. That means this is one part, okay? If you see, this is one part, this is second part, this is 3 part. So I have divided between 0 and 1 into 3 parts. Similarly, here also I can do, one part, second part, 3 part, third part. Okay, so between each division, 0 to 1 divide into 3 parts, 1 to 2 divide into 3 parts, because it is out of 3. Okay, now how do we count? See, now we can count. This is 0 by 3. The first division will be 1 by 3. Second division will be 2 by 3. So this is the representation. So this is how we represent 2 by 3 on the number line, because 1 will be anyways 3 by 3. That is how we get 1, right? So here 2 by 3 is the number on the number line. So this part is the 2 by 3 on the number line. Okay, we don't have to bother after 1, because this is lying between 0 and 1. So after 1 you don't have to, if you don't divide also it's fine. Only between 0 and 1 if you show, it's fine. Okay, now if we consider second example, if I consider 5 by 3. Now this also you can follow the same method. Okay, 0, 1, 2, 3 and so on. Okay, so here also now it is 5 by 3. We have to again divide into 3 parts, right? So we'll divide. Now this is 5 by 3, obviously it is improper fraction, it is going to be more than 1. Okay, so now if I represent, this is 0 by 3, first division 1 by 3, 2 by 3, this is 3 by 3, this is 4 by, you have to continue after this, 4 by 3. Now here we get 5 by 3. See, here we get 5 by 3. So it is, see, it is coming between 1 and 2. It is lying between 1 and 2. That means it is more than 1. So when we got the mixed fraction, see how it was? 1, 2 by 3. Mixed fraction was 1, 2 by 3, right? So if you consider that also, you will get the same position, right? So 1, so this is your 1, here 1. And this is 1, 2, 3 parts we divided, right? So this is the first part 1 by 3. This is the second part 2 by 3. If you consider this way also, you can show it on the number line 1, 2 by 3, or directly 5 by 3 also you can show. You have to divide between 0 to 1 into 3 parts. Between 1 and 2 also you have to divide into 3 parts. So both the ways you can write. Okay, whichever you feel is easy for you, you can write. Children, I hope you understood this topic. If you have any doubt, you can ask me, leave your comments. I will respond to that. Thank you. So the next topic now is the comparison of rational numbers. Okay, when two rational numbers are given to you, how can you say which is greater and which is smaller? Okay, how do we compare those rational numbers? We have to learn. Okay, comparison of rational numbers. This is our next topic. So there are two methods. Okay, there are two situations. Okay, where we follow different method. So we have first method, method 1. Okay, if the denominators, in method 1, if the denominators are equal. Okay, suppose if I say 2 by 7 and 3 by 7. Okay, now here denominators are same, then how do we write which is greater? We have to just see the numerator. Okay, now which numerator is greater? 3 is greater, so it's very easy to write the greater rational number. Okay, so it's very easy to compare the rational number if the denominator is same. I can take one more example, maybe 5 by 11 and 9 by 11. So here the denominator is same. So 9 is greater than 5. So 9 by 11 becomes the greater rational number. Okay, compared to 5 by 11. Okay. Second method. Second method, if the denominators are different, what do we do? If the denominators are different, what do we do? Suppose I take an example 3 by 7 and 6 by 11. Now here denominators are different. How do I compare? So what I do is, I will make the denominator same. One thing you can do is make the denominator same. Make the denominator same. How can I do? Just by seeing, I can say that okay, 7 into 11 and 11 into 7. Okay, 7 into 11 I'll get 77, 11 into 7 also. So equivalent fraction. So equivalent form I'm getting, right? So I'm multiplying with 11 in here in the denominator. Here also I have to multiply with 11. Here I'm writing 11 into 7. Here also I should multiply with 7. So here I get 33 by 77. Here I get 42 by 77, right? So here what do we do is, we make the denominator same by writing the equivalent forms, right? So here the denominator. Now here we made the denominator same, that is 77, and now we can compare easily because denominator is same now, and numerator you can compare easily. Now 42 is greater than 33, so I can put the greater than sign to 42. Okay, this is one of the method. Second method you can also do is by taking LCM. Okay, same question. If I say 3 by 7 and 6 by 11, so LCM of 7 and 11 you should take. LCM of 7 and 11, 7 ones are 11, then 11, 1, 1. I hope you know how to find LCM, children. So LCM of 7 and 11 will be 77 only. Okay, so here you can take same method. After that it follows the same method. Okay, we follow the same method here. what we follow here. So LCM method also you can apply, or you can go for the equivalent form. Okay, you can get the denominator same by writing the equivalent form of the rational number. Okay, so these are the two methods you follow to compare the rational numbers. Okay, so apart from taking equivalent form of the rational number, we have one more method that is a very shortcut kind of a method, which is the cross multiplication method. Okay, this will be easy for you to compare. Suppose if I take example 3 by 7 and 6 by 11, so I need to compare. Okay, so what you do is you cross multiply. So 3 into 11 you have to write left hand side, and these two numbers 7 into 6 you will write on the right hand side. Okay, now what we get here 33, and here we get 42. So it's easy to compare, right? So 42 is greater than 33. So I can say that 3 by 7 smaller than 6 by 11. Okay, this way by cross multiplication, it's an easy method of comparing the two rational numbers. You can make use of this method also in your exams. Now the third method in comparison of rational numbers is the last method, is comparing rational number on a number line. Okay, children, we have learned how to compare the integers on the number line in the previous videos. You can refer those videos. But here now we are going to compare the two rational numbers on the number line. So there is a different method which we need to follow here. So follow me carefully. See that what I am doing. You can later practice after seeing the video. Okay. Okay. So here I am comparing two rational number 2 by 3 and 3 by 4. Okay, now here I have to compare. I have to say which is greater and which is smaller. Okay, so for that, no, we need a construction here. Okay, we need to do a construction here. So here I will draw a horizontal line. Now I am showing 2 by 3 in the upper part of this number line. Okay, so here 2 by 3, how to draw 2, now how to show 2 by 3 part. Okay, so here first we have to draw an acute angle. Okay, this is an acute angle, right? You can draw acute angle of your choice. Okay, then this is what 2 by 3, it represents out of 3 2 parts, right? So with the compass you make 3 equal parts. Okay, so why 3 equal parts? Because this is 2 by 3, total parts are 3. So I have made 1 part, 2 part and 3 parts. So name it as A1, A2, A3. Okay, later what you do, you have to join it here on this line. So this is 0 and this is 1. See, now I told you this is a proper fraction. It is going to be less than 1. Okay, it lies between 0 and 1. I have already explained you that. So now you measure this angle. Okay, again with your compass measure this angle. Same measure you have to draw here also, and measure this part also with the compass. Same measure you cut here. Okay, so you will see that you can join this line. Okay, now this line if you join, this is 1 by 3. Similarly, if you follow the same method here also, take the same measurement of this arc with the compass, and this also same measure you cut here. You will see you can join this on the line. So this becomes 2 by 3. So here is my 2 by 3. Here is the rational number 2 by 3 on this number line. Okay, now 3 by 4. Now how do I show 3 by 4? For that what I do is 3 by 4, right? Now I'll make an acute angle below this line. Okay, now here it is 4. So now we will divide it into 4 equal parts. So 1, 2, 3, 4. Okay, now with the compass you take, with the scale you measure equal divisions and you make 4 equal parts. Name it as B1, B2, B3, B4. Okay, and then you join it with 1. Okay, now again 3 by 4 is a proper fraction. Its value will be between 0 and 1. Okay, now you see, now here if you measure this arc, same arc you can measure here also, keeping the compass here, and you measure same arc, and this this distance also keep it in compass and cut it here. So when you join it, somewhere you will see that it is going to be marked somewhere here on the number line. Okay, so now what is this? This is 1 by 4, 2 by 4, 3 by 4. So 3 by 4 is here. So when you see here, see 2 by 3 is on the left and 3 by 4 is on the right side of the number line. Okay, so we can say that 3 by 4 is greater than 2 by 3, because 3 by 4, if you see on the number line, it is on the right side and 2 by 3 is on the left side. Okay, so here you have to do construction and you have to see how you can compare the rational number by seeing their position. Okay, hope you understood. You try this at home. Okay, try to construct it using your geometry box. Okay, and then if you have any doubt, you can surely ask me. I will reply it. Or if you find this construction difficult, what you can do is 2 by 3, 3 by 4, write the equivalent form of it. Okay, make the denominator same. So here if multiply with 4, here I'll multiply with 3. Okay, so here I get 8 by 12 and here I get 9 by 12. So now I can represent it in the number line. So now it is proper fraction, so it will lie between 0 and 1. Divide into 12 equal parts. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so here you can represent now. So this is 0 by 12, 1 by 12, 2 by 12, 3 by 12, 4 by 12, 5 by 12, 6 by 12, 7 by 12, 8 by 12, 9 by 12, 10 by 12, 11 by 12, and this is 12 by 12, right? So now here is the 8 by 12 and here is 9 by 12. Now which is on the right side? 9 by 12, right? So 9 by 12 is greater than 8 by 12. That means what? 3 by 4 greater than 2 by 3. Okay, if you find this method easy, you can follow this method also to show the rational numbers on the number line. Okay, otherwise you can go for construction method.